Okay, so yeah, welcome everyone. Welcome to the F# Essential Lectures. Today is our last session. We have been running this initiative for now 12, 13 weeks, I imagine. I think, and really, thank you and congratulations to make it all the way through the end. We have, had a lot of fun and learned a lot. I have learned a lot. I'm sure you do as well. In all these weeks, we started, this with the idea of, trying to um, uh, amplify F# as the language and basically make the teaching resources available to everyone. So I think, I don't know what you think, guys, but I think we made it. We accomplished our goal, and yeah. So first of all, I want to say thank you. Thank you very much, Ian, for all the effort that you put in these lessons. The amount of the good content that you taught us over these weeks is awesome. So for this week we have, as the last lesson, we have a topic which is really popular on the .NET ecosystem, which is ASP.NET Core. So today we will be covering web pages and APIs. And just to a quick recap, that last week we did some computation expression fundamentals, compound effects, and the video is already uploaded to our website and also to our playlist. So you can watch the lesson on our website, or you can go to our YouTube channel and go to our playlist, and there will be one called Essentials Lectures. So yeah, you can watch all the previous lessons, at your own speed, and ask any questions over the comments. We will try to read them and come back to you. So yeah, really excited to finally get this done and to keep learning F#. So yeah, without further ado, Ian, I will hand over to you.
Thank you. So let's get that page up and running.
Yeah.
All right. Okay. So welcome to session 12, the last one. Yay. It's been a lot of work, a lot of fun, but a lot of work as well. So there's a lot of prep work that goes into all of this. So it'll be nice to have a little bit of free time now, although there'd be a little sad that that it's over. So the agenda for today is I'm going to do a quick recap on session 11 with computation expressions, and then we'll go on to ASP.NET Core. So computation expressions, there were 4 built in: sequence, async, task, and query. We haven't really looked at sequence, but it is quite a useful thing to have. So we did look at async, and we're going to look at task today. And query is basically the link query syntax, not the extension method syntax that goes with that. So there are 2 types of computation expressions. One is you can write your own functions, so you can write DSLs. So there's some good examples around. So Saturn's one that I'm going to mention later on. Farmer, which is for dealing with Azure deployments, and also FSHTTP, which is a nice little DSL for HTTP client. So it's a nice functional thing for that. What we're using them for instead, though, is we're using the built-in functions. So we're using things like let and use and do and, which are built in there to make our code a little bit simpler. I want to say it's syntactic sugar, but that would be doing it a real disservice. Computation expressions are really useful, and they really do tidy up your code in ways that a lot of other languages just don't. They get they can get very complex very quickly. So if we didn't have them, it would be quite difficult to do some of the things that we do with the ease that we do. And we also looked at combining effects as well. So looked at async and result in a combination. I'll show that in a couple of minutes. So let's quickly load up the async example from last week. So hide that. So this is a built-in part of the .NET frame of the F# core language. Just letting it catch up and come in. Right. So we've caught up now. So this is the computation expression. So the async with the curly brackets, and we're using let bang here. What the bang does is it removes the effect. So this is an file.read all bytes async is an asynchronous function that actually returns a task, and we haven't used task here, we've used async, so we have to use the async.await task function that will convert it into an async for us. And then what the bang does, it will give us access to the bytes that are inside it. So we sort of unwrap it. So this is the equivalent of async await in C#. But async is not eagerly loaded like task is. So this is so you basically, until you materialize an async process, it won't actually do anything. Whereas task is slightly different in how it works. Async also had cancellation token support all the way through before task did. Task has obviously now got cancellation support in version 8. So this is reading asynchronously a file and getting the bytes from it. We've got a non-asynchronous method here, which is just getting the file name from the path, and I'm just returning something. So this is one of the few times that you'll use the return keyword is inside a computation expression. I can also turn it into a task as well. So I'll just copy that one, just so that I don't lose it. I can make that a task quite easily. And if I do that, I need to get rid of that because it's already a task. And then when we come to use it, when it's an async, I just need to run it synchronously. I just need to actually get it to work. With it being a task, I need to add that async await task in there to convert it into an async to run it synchronously. When we get onto the web programming, we won't need to do this because that happens. All this running stuff happens behind the covers. We don't need to care about it. But in this particular situation, we do. So if I run this using .NET Run on the CLI, it should load it, and there I get my record coming out. So it tells me about the file name and the length of the bytes. Not particularly exciting, but it's at least it does show how they work. So a much more exciting example. If I can find it. So compound computation expressions. So this is a much more complex example that we went through, and this uses the fstoolkit.error handling library. It's all of these computation expressions that are not built in, it handles. So anything to do with options, results, and tasks outside of task itself, you can use the FS Toolkit error handling library, and that's what we did with this because we're using async and result. So in this particular one, I did some error types as well. So we've got 4 functions. We've got a function called try_get_user that takes a string and returns an async of user option. Then we've got a next function which takes a string and a user and returns a bool. So that's checking if the password's correct. Then we've got a simple authorization where it takes a user and returns an async result of either unit or auth error. And finally, we've got a function that takes a user and returns a result of auth token or token error. And then we combine them together. So we have a situation where we want to try to get the user. If the user doesn't exist, then we return an error. We then check if the password's correct. So we take the user that we got from line 78. So we unwrapped the async result, and we get the user out, and we can then use the user on the next line, and we check whether the password's valid. And if the password isn't valid, then we return an invalid password, and then we authorize the user. And if it doesn't get authorized, then we map the error that's returned from the authorize into the error type for the login. And finally, the last one, again, the auth token. If it errors again, we map that token as well. So to write that out longhand would be probably 4 or 5 times the number of lines, if not more, and it gets very complicated very quickly. But this comes out using computation expressions as something that's very easy to use and very readable. So they're well worth learning. So this is a compound effect, so async result. So you've got async and result in the output. So all the combinations are in FS Toolkit error handling. So if you've got things like so async result, task result is in there. I think there's still a task result option as well. So there are situations where you can have the next compound one on. So all the obvious combinations that there are all built into that library. If you're trying to use an unobvious one, then you're probably doing something slightly wrong. So that's computation expressions. Let's go back to the main file. Right. If you want to learn more about computation expressions, the best place still to learn more about that is Scott Voloshin's F# for Fun and Profit, and he's got a whole series of I think there's nearly 20 different blog posts on it. So it's really useful, and it's well worth looking at FS Toolkit error handling as well, having a look at the code, even if you don't really understand it at this stage, and maybe looking at Farmer or FSHTTP to look at how the DSLs work with their custom methods. So what we're going to cover today, so we're looking at using ASP.NET Core, and the F# web programming landscape is quite diverse. It never used to be that good, but things have got a lot better over time. So there are a few libraries that I want to sort of mention. So the first one I'm going to mention is Suave. So Suave is pre-ASP.NET Core. It's actually written. It doesn't use any of that at all, but it's a very lightweight library. It's quite useful. So I've used it a couple of times for a couple of projects, and it doesn't have all of the all of the baggage that ASP.NET Core used to have. So it's quite an interesting library to look at. Giraffe we're going to look at today. Giraffe is just a simple functional wrapper around ASP.NET Core. Then you have Saturn, which I mentioned earlier, which is a custom computation expression, and that's an opinionated wrapper around Giraffe, which is a wrapper around ASP.NET Core, and that basically makes your code look more like an MVC app, more like a Phoenix app from Erlang. So it's as I said, it's very opinionated. It's quite an interesting library, but it's something that I don't use. I have looked at it, but it's certainly good for certain scenarios. But I like the flexibility of Giraffe. You've then got Falco and Oxpepper. Falco is a relatively new one. It's well written, well supported. Oxpepper was written because Giraffe wasn't really being supported for a while, so there's a few new ideas in that. The next one is WebSharper. WebSharper has been around for a very long time. It's very different to everything else, but it's been used for a long time, very successfully. So it's certainly worthwhile considering. And the last one, which I'm not going to cover at all today, is the Safe Stack. And the Safe Stack is where a lot of the cool kids are hanging out in the F# world. So I think it started off as, I'm pretty certain it started off as Suave, Azure, and then you got Fable and Elmish. So Fable is an F# transpiler that transpiles to JavaScript and I think TypeScript as well. And then Elmish is a front-end library for managing web pages using model view update. So it's a very nice functional way of handling things being updated on a screen on a web UI. So I think the current meaning for safe is, I think it's Saturn, Azure, Fable, and Elmish. But I think it just means any Azure just means any cloud platform now. There's a lot of documentation around on SafeStack, particularly around Fable and Elmish. There's a really good Elmish book out there. It's an online book, and there's an awful lot of work being done in the Fable world for dealing with things like React programming as well. So there's probably more work being done on that side of F# than all of the other sides of F# put together, I would imagine, from the library's perspective. So what we're going to cover with this session, start off with getting started with F# and ASP.NET Core. What do you get from an absolute blank slate? Then we're going to install Giraffe, and then we're going to have a look at the interesting parts of Giraffe. So we're going to have a look at endpoint routing, and creating APIs and views. So I'm going to get started. Let's create a new folder called let's call it Giraffe 101. I'll come back to that in a moment. Right, so I'm going to start from the absolute basics. So we'll do a .NET new web -lang F#. Okay, there is a Giraffe template that you can install and use, but I'm going to do this from scratch rather than using that. So this is the absolute basic F#. Right, just letting it catch up so it comes into the F# editor. Okay, so this is using the new or newish ASP.NET Core endpoint routing system. So you can actually write a full app almost C# style if you wanted to. I'm not going to recommend it. I'm going to recommend that you use something like Giraffe instead, but you can at least do it, and it does look pretty much the same as the same thing in C#. The only difference here is that F# needs the entry point attribute, and you get an exit code on there. Other than that, it's pretty much what the out-of-the-box ASP.NET Core app would look like for C# as well. Okay, so next I'm going to install Giraffe. So these are two packages. So .NET package add. Get it the right way around. Okay, and I'm going to add a second package as well called giraffe.viewEngine, which we'll use later on when we get onto web pages. Okay, so that's my two packages in. What I'm going to do now is I'm going to copy a little bit of code over to save me typing all of the stuff that I'm going to cover. So what I've done here is I've actually copied some code from a blog post by Hamilton Hammy, and this is a nice starting point. So this is pretty much the minimum that you need to get started with Giraffe, and it's the same pretty much with C# and ASP.NET Core. You're never going to be able to do anything with just the basic template layout. You're always going to add services to your application, so you're going to end up with something like this anyway. So the bits that we're interested here is we're in the configure app, we're using routing and we're using the endpoints as well. So there's a built-in helper for us called map giraffe endpoints, and we've got a function here that or a value in this case, it's a value that's the endpoints list. We'll come back to that in a moment, and then we're adding the giraffe service to this. So this is the absolute minimum that we need. So the only difference now is that we need an endpoint. So I'm going to do the simplest endpoint that works. Okay, so I'll explain what these are in a second. I'll just get this to run first. Okay, copy the root. And this is HTTP client, so it's one of these extensions that you can now use. So if I go to localhost, just trying to find where this is a send request, and I get the message saying this is Giraffe. Sorry, that's just a little bit awkward. Right, so this line here is, so root is a built-in function. This is one of three that we're going to use today. And then this is a path. So in this case, I've decided to go with nothing at this point. And then there's a built-in helper function called text, and that just returns the text that I decide to type in here. So this, unfortunately, will take any of the HTTP request methods, verbs. So if I want to restrict it to just get, which I probably should do for this, I can use another of the built-in helper functions called get. So this will now only work for get. If I go to here and I choose post. Obviously that worked, and that worked simply because there isn't a built-in thing at the moment to automatically update your process. So there isn't a watch. So we actually need to stop it and run it again. So I know there is a watch, but I'm not running it. I'm just going to keep doing all of this. So if I do a send, I've now got a method not allowed. I'll clear that out. So that's making us, so that's now is restricting us to only gets. So another thing we can do is I can pass in a little handler here. I can pass in a little helper. So %s means it's a string. So now if I go fun name, oh yes, I'll fix that in a second. Right. So this is a slightly different route. So this is called route F. So this is saying it knows that I've got something that I'm passing in. So if I change that to welcome to Giraffe. Right, so stop that again. Run it. Go to my helper. Do /. and change that back to a get and send the request. I get the message saying, hello Ian, welcome to Giraffe. So all simple so far. Okay, so all I'm building up is the my collection of routes. So I've got two forms here. I've got one that doesn't take an input, and one that does at this stage. So this is really simple for as far as we've got now. Obviously, I don't want to write all of my code here like this. What I'd rather have is all this logic that's over here moved into a method. Sorry, into a function. So to do that, we can create our own handlers. So I'm going to create a one called name handler. So that's going to take a string, and I can then do copy that. I don't need that bit. Okay, I can get rid of all of that and just do name handler instead. Stop that. Knit again. Call that test. Send my request. And I get the message working. Okay, nothing very exciting so far. So this is actually a handler, and every single function that you do at this level will be a handler. This is one style of doing it, and there is another style that you'll tend to use instead, which is a bit more explicit than this. So this is a HTTP handler, and what I've actually got is I have a next, which is a HTTP func, and I have a CTX, which is a HTTP context. And I need to set that as well. Right, so you can actually combine handlers together. So next is the next handler, and context is the HTTP context. So anything that gets passed through, like query strings and services and various other things, come through the context. So if you want access to it, you need to set up your functions like this example, and it's a good habit to do that anyway. So we can stop that. again and run it. Make sure that it works. Okay, so that all works. So what we could do is we could then have things for post if we wanted to, and all of the other verbs as well. I'm not going to do that there. Now, obviously, in a big app, this could actually get very large very quickly, this endpoint list. So one of the things that you can do with the with this is to use a subroute instead. So, oops. So if I wanted subroute of API, for instance, and that then takes a list of endpoints. So again, I could do something similar to that. Put an endpoint in here. So I can do that, and I can actually move subroutes into their own files as well, which we'll show a little bit later. I'm just going to remove that for the moment. So any questions on endpoints at this point, or what we've done so far?
No, not so far.
Okay, good. It should be relatively easy to get everything working at this point. Okay, so that's everything for stage one. Yep, just checking my notes. So what I'm going to do now is I'm going to do I'm going to do a to-do app. Well, I'm not actually going to do a to-do app. I'm going to do quite a lot of it, but I'm going to do a to-do API to begin with. So the first thing I want to do is I want to add a new file. So I'm going to add a file above. It's going to be to-dos.fs. And I need to create a namespace, which I'm going to call Giraffe 101. And I'm going to copy some code that I've already done, just to make it a little bit easier to work with. So what I have here is I have I've basically got a to-do type. So I've got a to-do ID, which is a single case discriminated union. It takes a GUID. And then I've got a simple new to-do, which just takes the description. So that's so we've got basically models. And then I've got an interface for an I-to-do store, which has 5 abstract members on it. So create, update, delete, try, get, and get all. And then we've got a little implementation of the to-do store, which has just got a dictionary inside it. So it's a class type. Tell it's a class type because it's got the It's got the parentheses there on the type definition. In this case, there's no input parameters at all. And then I've implemented the interface with the 5 members that it had. We're not really interested in that. This is just to get us up and running and working. One thing I do need to do is I need to add the I2Do store to the services. So to do that, I need to come down here. I need to add a singleton. This is going to be a singleton of I2Do store. So I don't have access to this at the moment. So I need to open Giraffe 101. So I2Do store. And then implement an instance of it. I think I covered ignore previously in a previous session. Since everything in F# is basically an expression, by using ignore, you're saying we don't care about the whatever comes out of this expression. So we don't care about the iService collection that's coming out of this. If you don't do that, you'll actually get a compiler warning. But it's just nice to stick the ignore on there just so you don't get that warning. Okay, so that's added my service. And what we're going to do is we're going to get access to that via the context. So when we start building our handlers, we'll be able to access this this dependency. So that's our to-do store done. So what do I need next? Well, since this is an API, there are a few things that I need to do. So I'm going to start from the wrong place probably. So I'm going to start with the endpoints. Now, obviously, this is a namespace, and inside a namespace, I'm only allowed to have types and modules. And this is a value, so it's not a type. So I need to put this inside a module, or I need to put everything inside a module. So I'm just going to create a quick module at this point. So this is my to-do endpoints. Okay, so I have all of these here are part of Giraffe, so I need to open Giraffe.endpoint routing. Okay, and the other ones, we haven't got those yet, but we will have them at some point. So in this particular case, I've got 2 gets, so I've got the ability to view a single to-do, the ability to view a list of all the to-dos. I've then got a post, which has a create, put, which is the update, and delete, which obviously is the delete on there. and I need to plug this in now as well. So I need to tell the routing system that that you can use this. So we go back to program, go back into my endpoints. So I'm saying that there's a subroute called API, and then there's a subroute inside that called to do. So if I have, so if I had customer, I could easily just add another subroute. I could copy this. So it's quite easy to do and quite compact. So I'll get rid of that so I don't need it. So I've got API to do that. I need to access the module. So I've got access to that already. I could just do what did I call it? So to do endpoints. So that's probably the easiest way of doing it. So one of the things with writing things in F# like this is that the first thing to do is probably just to get it to work. And then once you've got it to work, have a think about tidying up so it becomes a lot easier to work with. But obviously there are limits to that. You don't want to take it too far because it can be quite hard to refactor things, lots of things. But if you can generally get it working reasonably well, you should be able to move stuff around fairly easily, because obviously you've got things in order anyway. So that seems to be working. So let's go and have a look at the to-dos. So the only thing that's now missing is I don't have the handlers. So let's go and create a module for the handlers. And I'm going to copy and paste that as well, because that's it's not whilst there isn't a lot in there, it's not there's more than I want to actually type. Okay, so let's copy that for the moment. I don't know how many of those I actually need. Looks like I don't need many of them. So let's get rid of the ones that I don't need. That looks okay. And obviously I need to tell it to use the module. So to do handlers, that fixes that. So let's go and have a look at these handlers. So these handlers look exactly the same as the one that we did in the example. So go back and have a look at the name handler. So it has a parameter. It's a HTTP handler, and it's taking it's got a next of HTTP func and a context of HTTP context. So in this case, you can see that I'm using the get service method of the context to get access to the I2Do store dependency, and then I can use that to get at my data. So I might tidy that up a little bit. So so this is a to do equals. Let's move that. and JSON is a built-in helper function to Giraffe, which obviously creates JSON from our to-do. Again, I'll do the same with the all, so it's a little bit easier to follow. Okay, so the next interesting one is the create handler. And what we obviously do there is we will have some payload, so that we can use the bind JSON async function that's built in to strongly type our JSON payload into a new to-do, and that new to-do just has a description field, a description property rather, on it. And you can see there that we do exactly the same. So we get the to-do, we then create one and add it to the collection, and then we return. And this one's inside a task computation expression, because the binding to the JSON is asynchronous.
We have a question in the chat.
Yep.
So it is about constructor injection. So David asks, I would assume that it's somehow possible to use constructor injection rather than doing what you show the example,
Yes.
whereby you can do context get service and then pass the I-to-do store interface.
Yep. So the other way is to pass the dependency in as a parameter on the function. So what you basically do is inside of the configure services, you would set that up. So you define all of the you define your dependencies at that point, and then you pass them down to each individual function that needs them. I don't think it matters either way, to be honest. You know, you don't quite have things like constructor injection. It's not quite as simple as that, but you do have certainly functions. To be honest, I'm quite happy with this. I'm quite happy with this service location. I know a lot of people aren't, but
yeah, this is idiomatic too, basically, to ASP.NET Core. So, it's, one of those things where I think it's better to use what the ASP.NET Core is offering you at this stage.
Yeah, I don't have a problem either way, to be honest. I think it's I don't generally have that many dependencies anyway, so it's not really that much of a problem. But I don't pass the context down further than the handler. So once you get beyond the handler, then I'm passing as parameters to a function. So if I need something further down, then it gets passed down as a parameter each time. So it's not something that I deeply get involved in. But I know there are other ways of doing it. There are lots of there was a blog post written by, I can't remember who it was now, that explained probably half a dozen different ways of doing all of this using monads and all sorts of things. I'm all for simplicity. You want to chime in on this, Jimmy?
I do. I have
Go on, then.
I've done a lot of these in various things. So I'm gonna kind of go through like slight differences in the things here. So what people are familiar with is typically constructor injection. This is what ASP.NET provides, and this is kind of like I'm going to ask you that question directly. With Giraffe, you're typically using F# functions, and so you don't usually have objects. That doesn't mean you can't create objects, but you are still going to be calling context.getService. There are libraries that kind of can do the thing where you just say, give me a function and here's my services, and it will call get services on your behalf. But it's at that point, it is the same as doing that. It's just hiding it under a rug. Constructor injection is still the same thing to me, honestly. It's hiding get context under a rug or get service. That, so but I do understand if you wanted to look at this from a functional point of view, like what dependencies do I take? You could also then extract the lines from like 70 or 63 to 71 out into their own function that do take in an I to do store and a JSON thing. So you can actually get, or you can actually see like this is how the dependencies are actually displayed on the function. It's on the tin. So there are lots of different ways to kind of deal with it, but as Ian said, it's kind of all just the same, really. I know people are scared because they've seen a blog post that says don't use this pattern, but it's all the same.
Yep. The bad thing is if you overuse it, it's not using it that's the problem. So generally in my systems that I've used, I've probably had no more than half a dozen services that we've been working on, sometimes a few more, but certainly not many. They're just things that I don't own that make testing slightly difficult, and this is one of those.
Yeah. And also, Tim, I think, mentioned in the chat that the context is a mandatory parameter as well. So, you have access. It's a quickly access to that as well.
Yeah. It's odd that people will rail against using get service, but won't rail against using bind JSON async. It's still just a function on an object. So yeah, I really don't see the issues that people have with this sort of thing.
So we have another question. It says that how do you deal with cross-cutting interfaces? Example, iLogger. I would prefer not to have to pollute my function signature, especially if logging happens at the bottom of the code stack if possible. Good question.
There's nothing you can do if you don't make your call stack too deep would be one. If you use it, you've got two options. You either pass it down explicitly or you pass it down as something attached to something else. But the way that functions work, you've got to pass dependencies down the call stack. There's nothing you can do about that. It's not going to magically. You can't. It's. I suppose you could use global dependencies, but then you're magically making things appear. And the whole purpose of F# and functional programming is that everything is obvious. You should be able to look at a signature and know what that thing. I know that's why people don't like things like service location, because it's not the same as dependency injection, because you can't see what's being injected. Although the mechanism's basically the same thing, it's the whole idea with functional programming is that I look at a function, I can see what's coming in and I can see what's coming out, and it's very clean and obvious to me. So that's what you basically have to do with a logger. If you need a logger and you've got a call stack that's 5 things down and you need the logger in the bottom thing, you've got to pass it down. Sorry.
Yeah, good. Yeah, that's basically what someone suggested today, some sort of a static logger or something like that. And Jimmy, I think, has a library or something like for that kind of stuff when you use Serilogs or you need some logging. So Jimmy always has a library for save us.
Yeah, I'd take being obvious over clever solutions every day, even if it means a little bit of extra work. You can always use partial application anyway, to stop a lot of this. So you don't need to make it quite so obvious. Any more questions?
Nope. I think we are good to continue.
Okay, so what I might as well do then is attempt to run this. Let's see what we've got. Hopefully it builds. Okay, so let's have a quick. So my subroute is API and to do. So if I want to create a new API, if I want to create a new one, then I'm creating I need a JSON document. So let's work my way up through the list. So API to do. I'm creating, so it's a post. Oops, it's JSON, so I need quotes around it. It's a new to do. That looks relatively okay. So click on send request. I get a true, which doesn't really tell me anything, but I wrote the API, so hopefully that works. So if I now do API to do, I think if I do a get on that, that should return me all of the documents. I've got one there, so that's the one that I created. So if I take the key from there, I can add that to the route. That's a get. I'll send a request. Now that's no longer in an array. That's just a single item. I'm not going to try anything else on that, but so that basically works. So creating an API is really quick, really easy. So it's all about designing your endpoints, plugging your endpoints in, and then creating the handlers. And then you can obviously create things underneath that as well. You've obviously got types and various other bits and pieces, but it's relatively quick and easy to do all of this. It's not rocket science. So building APIs with Giraffe is really simple. It's really quick and easy to get up and running. If I haven't covered anything that's on here, generally the reason I haven't covered is it's either not to do with web programming, it's sort of other F# stuff that we've already covered, or ASP.NET Core does it. So you'd be doing it with C# anyway. So I'm looking more at the differences between what we do in Giraffe in an F# compared to what you do in C#. So that's the API side. And now we move to the browser side, to the web forms version. Now I'm not going to go too far into this, but we need to do some setup first before we go any further. So I want to go back to the normal Explorer view. I'm going to add a folder called web root. I'll add a file called main.css. Let's have another one as well. Okay, and I'm going to add that to the project and tell it to use that. So I'm going to actually edit the project file itself directly. Find my bit of code. So all I'm doing here is just telling it to copy the bits that it needs from the web root folder to the output. So what else do I need to do? I need to tell it to use static files, which goes in here, which goes into the configure app, and then I need to add a couple of lines to the main function as well to tell it to plug in the bits that I've just done. I need to create those two, content root and web root as well, automate it. Oops, I'm a level too low. And I need to add system.io as well. Okay, that's all the configuration. So I've added use static files. I've added I've done something to get so I can get a content root and a web root, and I've added those into the web builder, just setting it all up. So this is just setting up so that I can load the CSS and JavaScript files that I've included. So that's it for the configuration. So the only other bits that we have now is actually doing HTML. And we loaded the Giraffe view engine earlier on, so we're going to use that. So let's normally we'd see HTML that look like that, and obviously the if you use things like Razor, then you keep writing HTML in that particular style. The Giraffe view engine takes a slightly different view of the world. And what they do instead is to use a strongly typed version instead. So I need to open the view engine. Okay, so what we have is we have values built in. So HTML takes a list of attributes and a list of items, in this case, a special type called an XML node. And head is the same as well. So title's the same. Link is slightly different in that only takes a list of attributes. So what we're basically doing, so this is strongly typed. So if it doesn't line up, so if you don't nest things properly, if you don't end correctly with the square bracket, etc., then the compiler will tell you that you've made a mistake. But these are still just functions. So in this particular case, we've got a master page that takes a string and some content. So what we do in the index page is all we're doing is building the content and passing that into the master page along with a message that goes on the title. So when I first saw the view engine, I was slightly less than impressed. I come from a world where you write HTML. I'm quite happy writing HTML. I didn't particularly like Razor, but at least it looked like HTML. And it took me a lot of persuading to actually come and enjoy using this. But actually, it turns out to be quite nice to work with, because it's all functions, it's all strongly typed. It was you just get used to it in the end, I suppose. So how do I get this to work? So I've got an index view. So if I go to find my router, so if I change let's put one in here then. So that's a new route. Let's call that /HTML. And it's called index view. And there is a little helper, just like there is a JSON helper. There's something called HTML view. Which will create the HTML automatically for us. So if I stop this, run it again. Okay, if I go back to my everything back to my HTTP. Okay, let's get rid of that. So this is my root is HTML. It's a get because it's a browser page. Let's clear all those out of the way so I know where I am. Send the request, and obviously I'm using an API helper here. So this isn't a web page, but it's built the HTML page for me. Okay, so if I want to use yeah, so that has got my CSS in it. So if I go back to go and have a look at this, so you find the link here. So I've got a style sheet, and it's pointing back to the main CSS. So that was loading the CSS, or it would have loaded the CSS in a web page from the web route that we've set up. Obviously, there is no CSS in there, but if there had been, so if I go and find a second whilst I find my my CSS and JavaScript.
While you are doing that, I just want to mention that basically here's where the versatility of the DSLs on HTML and in the community, that there are multiple options that you can use.
Yes.
View engine, Felice, and something that they use more like a list builder approach, something that uses computation expression. So
yep.
that's
there are quite a few libraries out there for views. There's even a Razor view engine for Giraffe as well that I think is still supported. And that works pretty well. But yeah, this is but from a perspective of if you don't build that many pages, this is a perfectly legitimate way of doing it. Obviously, it's not going to work well if you deal with third-party consultants or designers and people like that who work in HTML, because you've then got to convert what they do in HTML into this style. So there are there are other considerations in there as well, along with making things relatively simple to use. But because it's all functions, it's quite easy to work with. So because these square brackets are lists, you can actually use list comprehensions to build up things. So if you've got a list of to-dos, for instance, you can do a for loop on the items and just build a little fragment of HTML through a new function. It's really easy to use this sort of stuff together. You know, if you're going to do more complicated UI stuff, then you should be looking at things like Fable and Elmish and the Safe Stack rather than this. This is very much more a if you build simple websites with tables and things, and that's the sort of thing that I do. I'm more of an API person than a UI person. But certainly, you know, if you're quite happy with server-side stuff and you're doing relatively simple websites, then this is a perfectly legitimate way of doing it. If you want to get more into web programming, then I really do suggest that you look at the Safe Stack to do that. And with that, I'm going to stop. So Giraffe's really useful. Really, it's a really good product. It works really well, and it's a fairly simple thing to work with. So you can use all of the things that we've used over the last 11 weeks or 12 weeks within this, and it works really well.
Yeah, and also, you know, the fact that I think one of the strong points of F# is backend and web development as well. You know, as the ecosystem moves forward and we interact with JavaScript, you know, with the JavaScript ecosystem through Fable or to Web# or anything, it basically, you know, you will have almost full support for everything that is in JavaScript here. But you will need to write a wrapper around that to be able to consume those third-party libraries. But yeah, in my opinion, you know, F# it shines really onto web development and the backend development as well as other things, you know.
Yeah, for APIs, it's fantastic.
Yeah, definitely. Databases as well. There are a lot of libraries to consume databases as well, as you show us in the previous session. So yeah, I mean, you can develop, you know, really complex systems and businesses with F# and all of the libraries, the community libraries, as well as the Microsoft libraries.
Yeah,
right.
I'm wary of using words like complex.
Yeah.
You can build powerful systems, but they tend to be a lot. I find F# a lot easier to work with, and the solutions that I write are much simpler than what I come up with C#.
Yeah, that's my experience as well. I mean, I'm more of a mobile developer, so I have to say that, you know, one of my goals has been for the last 2 years is to offer desktop and mobile support for F#. So it's been a journey, but yeah, all of that, you know, you have told us over these 12 weeks. Yeah, it's really useful for me as well. So that's it for the last session for today. I imagine so. I want to say again, thank you, Ian, for all you have done over these 12 weeks. We cannot thank you enough for you know, making this happen, for being so, you know, open to this, and from the Amplifying F# team that we are here on as well on the session, we want to, you know, express our gratitude, and you know, I want to you know, reach out to you personally, that we're both in the UK, and you know, celebrate this accomplishment, and yeah, hopefully I will see you on the Domain Driven Design Southwest over the weekend. If not, I will get in contact with you.
I'll be there on Saturday.
Yeah, I will. You know, I will make sure that we meet and we celebrate this. So yeah, I think we also have some thanks from the chat. So yeah.
Yeah, I've enjoyed it. It's been It's been hard work, as I said, but yeah, it's fulfilling anything that helps F# move on, anything that spreads the word a little bit more and makes it easier for people to pick up the language. Then it's worthwhile doing.
Yeah, definitely. And that's why we are here, to facilitate this and to work together to make a difference. And we don't need to wait for any any foundation or any big organization to tell us what to do with F#. We can do it ourselves. So it's this initiative shows that. So thank you as well to Maya, to Tim, to David, for sticking through the end of the course. It's been really interesting, and we hopefully will be doing more of this in the future. So the idea is I want to be able to maybe take a month off and then create some bonus sessions. Like, now that we know the essentials of F#, we have learned over these 12 weeks. Now we can maybe have some bonus sessions about mobile desktop development, maybe trying to do something like, with all of this knowledge that we have we got over these 12 weeks, we can build something like like a bonus session or something like that. So stay tuned. We will work on that, and now we will announce it as usual on our socials, Twitter and Mastodon and all of that. And I will see you around. And again, thank you very much for the attention, and from the Amplifying F# team, thank you for joining us over these 12 weeks.